This is UASB Research. I'm Kara.
I'm Jaheen.
And I'm Raphael.
This is our final presentation. Why wastewater treatment? So in many small rural communities, getting access to wastewater treatment can be a very difficult task. So they are forced to release their wastewater directly into the environment untreated. This is not good for a number of reasons. One, it's a huge public health risk because wastewater can contain a lot of nasty pathogens, such as the stuff that causes cholera, salmonella, and diarrhea. Two, wastewater contains high levels of nitrogen and phosphorus, which cause algae blooms, and sometimes wastewater also contains heavy metals or other inorganic materials that can pollute the environment and even kill wildlife. So it's obviously not good, but it's hard for communities to get access to this kind of wastewater treatment. Like, think of a traditional wastewater treatment plant in the United States. They're very large, require a lot of land, are expensive to run and maintain, and it takes a while for them to start up. So what do you do about this? Well, UASB thinks we have a solution. An upflow anaerobic sludge blanket reactor is a form of primary wastewater treatment. It's pretty simple in its design. So basically what happens is the wastewater will flow down an influent pipe, as you can see in the slide, where it will then be released at the bottom of the tank. The water is then forced to flow up through what's called a sludge blanket, which is basically a composite of millions of anaerobic bacteria who will happily eat the organic pollutants found in wastewater. The organic pollutants are taken out, while methane is produced as a byproduct, which can actually be collected and used as biogas for cooking or other source activities that require fuel. So that's really cool. So the awesome thing about our design is it is completely gravity powered. It works very similar to a drinking water plant, an aqua drinking water plant, where as long as it's placed downhill of the community it serves, water can just flow naturally by gravity into the UASB. It is also can be small scale, and it's simple to fabricate. Doesn't require any really expensive parts or complicated parts. So what we've been working on this semester, UASB has been going on for a while now, but one of the things we've consistently struggled with working with is our inlet system. Basically, when wastewater is flowing up, we want to make sure it is evenly distributed throughout the sludge blanket. This is because if it's only going through a small part of the sludge blanket, only a small amount of the bacteria are actually working to clean the wastewater, and therefore a lot of bacteria are basically doing nothing, so this is not very efficient. So we want the wastewater to really be going through every single part of the sludge blanket. One thing, our first goal of the semester, we upgraded our inlet. We lost our old inlet, unfortunately, but that was okay because we needed to design a new one. So as you can see at the picture to the right, it looks a lot nicer. We're very happy with it. And we ended up doing a couple more things. So I will pass over to Jean.
All right. So if you don't know, last semester we did a tapioca testing. What we did was basically put tapioca in our simulated reactor tank and put dyed water through it to check how much preferential paths were forming, or how much the dyed water were congregating in an area, to check whether our inlet system was distributing the water properly through our simulated sludge blanket. Although we didn't learn much from this test, we did for sure see consistent formation of like preferential paths or congregation of dyed water within the tapiocas. So we were wondering whether it was like a flaw in our inlet design, and whether we could design a new inlet systems that would allow for better distribution or equal distribution all throughout this sludge blanket, so that could directly translate to more efficiency within the actual reactor tank. So first we started brainstorming, and we came up with two different designs, one with 2 pipe and one with 4 pipes. The 2 pipes would just go in from the side and have 2 different pipes going in to the reactor tank, and then the 4 pipe system would have the inlet system going in from the side, and then 2 different pipes going in the back and then in the front. So that way the water would distribute more evenly. Because the 4 pipe water system would allow for more distribution, we decided to test that. And as you can see in our actual reactor tank, we had to put in the inlet system from the top because it would not fit from the side, and that wouldn't really make a big difference in our water distribution system, so we decided to ignore that. So our research options were putting in tapioca to the same level and checking whether the red dye went through the water system, the sludge blanket more evenly. And as you can see, the red dye first congregates in the bottom for a little bit in the initial phase and starts going up. And after the initial phase, it starts distributing pretty evenly throughout this sludge blanket, and you see very little to no preferential paths. So as you can see, this red dye is more uniformly distributed within the tapioca, which means that more sludge has access to the water, which means more bacteria will be able to be killed or get rid of, and this correlates directly into our hypothesis whether the four opening system would work better to distribute the water more thoroughly throughout the sludge blanket. So now I'll give it off to Rafael to talk more about our initial phase of the inlet system.
Okay, so UASB design a few semesters ago, we decided to make a tipping bucket for the inlet system. However, we never get into really serious and focus on getting the distribution system. So therefore, this semester we kind of like fabricate a new system, the tank, which you can see from our slides. So it has 4 pipes underneath the system, which will carry the wastewater into the reactor. And we're gonna pour it manually because it's hard to fabricate in the lab with the real system. So we're gonna just pour it manually by our hand, and we're gonna pour around 500 milliliters of water. So how we gonna measure the volume of the water that's distributed in this system? We're gonna use the 4 small bottles, and then we place it underneath the system. And then as you can see from the picture, we kind of make it work by putting the system on the reactor tank and the wooden on the plastic container, and put the wood on the top just to make it happen. And we also are gonna pour the water from each side, and we want to make sure that we want to see if there's any different of the volume water depending on the orientation where we pour the water. And so this is the video. Yeah, on the video, you can see how we test it out. We pour the water from each side, and by collecting this water, we note that there are several volumetric differences in the water distribution between the bottles. But throughout our statistic data what we collected, we see it's fairly equal, and also we suggested that the inlet system will distribute water more unevenly in the reactor tank. And also, although the test was a proof of the concept, due to the limited time we have this semester, we were not able to truly test whether an evenly distribution of the water will directly translate to more efficiency, which we look into next semester. And for the next slide, we want to talk about our future work. So in this summer, the UASB team will stay in Ithaca, and they are going to work with the Ithaca Wastewater Treatment plant, where they're gonna put our the design and test it out. So whatever outcomes of this summer test will strongly influence what we're gonna do in our team and UASB team for next semester. Few ideas have been floating around, such as working on the dynamics of the sludge blanket, and also how long it takes to grow the bacteria, and how long does it take to settle after a pulse of water, and etc. But the team will most likely focus on researching, solving problems that are discovering in the process of making and testing these mini reactors. Okay, and if you have any questions, this is our contacts. Thank you so much.